All right, so we've got our next lesson here for Chapter 5. We're talking about factoring trinomials, factoring our quadratic equations. And we've got a couple of warm-up problems here just to review from the last time that we were doing this. I'm going to do number 3. And the directions say factor the following trinomials, but check for a greatest common factor first. It'll make our lives a little bit easier. Notice how in problem number 3, I have 2a squared plus 2a minus 24. And hopefully you all are saying that each one of these is an even number, and these 2's here mean that I can take a 2 out of everything. So I'll take 2 out, and if I take 2a squared divided by 2, I'll be left with a squared. 2a divided by 2 will leave me with just a, and negative 24 divided by 2 will leave me with negative 12. Now I want to factor out whatever's left here in my parentheses. In order to do that, I'm going to set up my x method, multiply on top, add on the bottom. What I'm trying to do is fill in my parentheses here. And with those parentheses, I would for sure have an a and an a. But in order to figure out if I'm going to add or subtract and which numbers they are, I'll go back to my x method here. I want to multiply to get the last number in my parentheses. From our last lesson, we talked about how the only way I get the last number is by taking the two numbers of my parentheses and multiplying those together. So that's going to be my multiplied number. And to add, I get whatever number is in the middle, the coefficient on my middle term. And on this one, we have a hidden number 1 here to add to get our middle term. So we'll have a positive 1. Now, in order to multiply and get a negative number, one of my factors has to be negative. The other one's going to be positive. Now I have to figure out which ones have a difference of positive 1. So out of 12, my factors are 1 and 12, 2 and 6, and 3 and 4. Hopefully you would all be saying that 3 and 4 are my factors that I'm going to pick. And in order to get a positive 1, I would make this negative 3, positive 4. Because 4 minus 3 would give me a positive 1. So in my parentheses, I'll fill in negative 3, positive 4. Now you could write those in the other way as well. You could have said a plus 4, a minus 3, and you would still have a correct factor set up there. But now what happens when we can't actually take that greatest common factor out? What if the thing in front of my a squared here had been a 3? Well, then I wouldn't be able to take it out. What do I do then? We can still factor those. We're going to use a method called slip and slide. We're going to slip first. First step, slip a, the very first number that we have, to the end of our trinomial and multiply it by that last number, c. Whatever c is gets multiplied by a. And we'll have a new trinomial. We'll have x squared plus bx plus a times c. So that's what our new thing would look like and where we get all of those numbers from. Now, once we have that factored, we're going to divide our factors by the value that we slipped. So I would have my two parentheses set up. I would have maybe x plus a number, let's just say 5, and x plus 3. I would need to divide both of those by a. Now, any factor that remains on the bottom is going to slide up in front of x in our factors that we have. So we would have maybe something ax plus 5 and ax plus 3, something like that. And so then we can always distribute and check that answer just to make sure that we have the right factors. So I'll do a couple of these examples here. I'm going to do example 1 and example 4. So I've got 2x squared plus 5x plus 3. Hopefully you're saying that none of these have a greatest common factor other than 1 because those are all prime numbers. So I can't take anything else out of those. So I know that I need to slip, first step, slip 2 times 3. So my new trinomial will say x squared plus 5x plus 6. Well, this is what we've been doing. We've been factoring these here. So let's actually factor this one. Let's set up our x method. And I'm going to have my two parentheses, x and x, because that's my variable. So I can fill in my variable. I'm going to multiply to get the last number, which is 6. Add to get my middle number, which is 5. 6 only has so many factors. 6 has 1 and 6, 2 and 3. And so hopefully you're all saying that 2 and 3 would be the two factors I would pick that multiply to give me 6, but add to give me 5. So I would have x plus 2, x plus 3. Now, in the past, we've said, yep, that's my final answer. I can't do anything else with that. That would be my two factors. However, if I were to distribute this right now, I would get back to this step here, not my initial problem. So what I need to do now is, this was step 2. Now I need to do step 3, which says I divide my factors by what I slipped at the beginning. I had slipped 2, so I'm going to divide both of these by 2. Step 4 says I'm going to reduce these fractions if I can. So x plus 2 divided by 2. 2 divided by 2 would give me x plus 1. But for my other factor, I can't take 3 divided by 2 and get a whole number. So what I'm going to do instead is I'm going to take and slide, this is where the slide comes in, slide that 2 in front of my x. So my second set of parentheses will say 2x plus 3. Now I can distribute this and double check. I'll take x times 2x, x times 3. 1 times 2x, and 1 times 3. If you simplify all of that, I would get 2x squared, 3x, 2x would give me 5x combining those like terms, and 1 times 3 would give me 3, which is what we started with at the beginning. So this, two factors here, would be my final answer, x plus 1 times 2x plus 3. So let's try example number 4 here. Let's give that one a go. So we've got 12c squared plus 11c minus 5. So again, we'll do the same thing. I have 12, 11, and 5. Well, 11 and 5, those are again prime numbers, so I can't take a greatest common factor out of all three of those. So my first step is to slide 12 down to negative 5. So I'll take 12 times negative 5, and my new equation will say c squared plus 11c minus 5 times 12 would give me 60. So now what I need to do is I need to figure out what these factors here would be if I were to factor this out like our normal trinomials. And so I would fill in my parentheses with c and c. I have those two variables that I can fill in. And I'm going to set up my x method. I'm going to multiply to get the last number, negative 60. Don't forget to take the negative sign with it. And I'm going to add to get my middle coefficient, that 11. So we'll list the factors of 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. So now out of all of those, man, that's a lot of things to look through. I know for a fact, though, that in order to multiply and get a negative 60, one of my factors has to be negative, one has to be positive. So in order to get a positive 11, I need to take my smaller factor subtracted from my bigger factor. It's the only way to get a positive. So I would go through 60 minus 1 would give me 59, so that's not it. 30 minus 2 would give me 28, so that's not it. 20 minus 3 would give me 17, we're getting closer. 15 minus 4, oh, that would give me 11, so I would have a negative 4 and a positive 15. So in my factors, I would have negative 4, positive 15, Again, this is not my final step now because I need to do the second part. I slipped in step 1. Now I need to do the slide. I would need to divide, step 3, divide both of these by 12. Now, I might not be able to take a perfect number out of these, but I can reduce these factors, or these fractions, by thinking of the factors. 4 goes into 12 3 times. So I would have c minus 1 over 3. 15 and 12 is a little bit trickier, but they both are divisible by 3. If I take 15 divided by 3, I get 5. 12 divided by 3 would give me 4. Now, this is not my final factor still yet. I need to slide my factors out for step 4. And so my final answer would be 3c minus 1 times 4c plus 5. We had 2 factors that we had to slide out of this one. Again, we can check our answer. I'm going to just check it over here off to the side. If I've got 3c minus 1 times 4c plus 5, 3c times 4c, 3c times 5, negative 1 times 4c, and negative 1 times 5. Now, when I multiply this, I should get back to what I started with here. 3 times 4 would give me 12. C times c would give me c squared. 3 times 5 would give me 15, and there's a c. Negative 1 times 4 would give me negative 4c, and negative 1 times 5 would give me negative 5. Combine my like terms in the middle, I'll have 12c squared plus 11c minus 5. That checks out with where I started with, so this would in fact be my factor pair here. So we'll give a couple of examples a try here today. We've got a few that we can do here. So let's go with, let's do 2 from the top and 1 from the bottom here. So we've got 2 examples, 1 through 6. Do 2 of those. And then for examples with the greatest common factor, meaning that we want to take something out of both of those terms, so we'll want to do a greatest common factor on those. Check back in once you have those done, and we'll see you later.